You know, every single day, you and we put our trust in countless digital systems without even thinking about it. Shopping online, checking email, logging into work, all of it depends on this invisible layer of digital trust. So today, we're going to pull back that curtain and look at the hidden architecture that makes it all work. Right, let's just jump straight into it. You see this little padlock icon in your browser all the time, and we've all been taught that it means secure. But what does that really mean? How does your browser actually know it can trust the website you're on? Well, that's the mystery we are solving today. So what it all boils down to is identity. That little lock is basically the digital version of someone showing you their driver's license to prove they are who they say they are. And as it turns out, proving your identity on the Wild West of the internet is a pretty fascinating and complex problem to solve. I mean, think about it for a second. When you go to your bank's website, how does your browser have any idea it's really the bank and not some incredibly convincing fake designed to steal your password? And then, on the other side, how does the bank know it's really you trying to log in? That is the absolute core challenge of online security. Well, the solution is, kind of funny enough, a really old-school idea. When you need to verify a super important document in the real world, what do? You go to a notary public, right? A trusted third party? The internet needed the exact same thing, just in a digital form. So this digital notary, it's called a certification authority, or just CA for short. Its entire job is to be that trusted middleman. It checks an entity's identity, like a website or a company, and then issues a digital certificate saying, yep, I've checked them out, they're legit. The best analogy really is a passport agency. You show up with your documents, they verify you're a citizen, and they give you an official passport that other countries will trust. A CA does precisely that, but for the digital world. Now here's where it gets interesting. Not all CAs are the same. Just like you have a driver's license for driving and a passport for travel, there are different flavors of CAs for different needs. The two main types are Enterprise and Standalone. And for any big organization, picking the right one is a really important decision. Okay, let's break this down. On one side, you have the Enterprise CA. This thing is deeply woven into a company's internal network. It's Active Directory. It's perfect for big companies because it can automatically hand out certificates to employees and internal computers. It's basically like an automated ID badge system. On the other side, you've got the Standalone CA. It stands alone. It doesn't need all that integration, which makes it way better for public-facing stuff, where you might handle requests one by one, kind of like going to the DMV. So this brings up a really great question. If a CA vouches for a website, who vouches for the CA, right? You can't just have someone pop up and say, hey, trust me. The answer is a hierarchy, a structure that we can think of as a pyramid of trust. All right, so let's start at the bottom of this pyramid. Here we have the issuing CA. These are the frontline workers. Sticking with our passport analogy, this is the local passport office down the street that you'd actually go to. It's the part of the system that interacts directly with end users, the websites, the people, the devices, and hands out the actual certificates. Okay, so moving up a level from those issuing CAs, we find the intermediate CAs. Now, these guys don't usually talk to the public. Their job is to give authority to the issuing CAs below them. They're like the regional headquarters that oversees all the local passport offices, setting policy and making sure everyone is following the rules. And that brings us to the very peak, the apex of the pyramid, the root CA. This is the ultimate source of all trust in the system. It's so trusted, in fact, that it doesn't need anyone else to vouch for it. It signs its own certificate. Every chain of trust for every single certificate eventually leads right back here. In our analogy, this is the main national agency that designed the passport in the first place and has the final say on everything. So, if the root CA is the single most important piece in this entire puzzle, the literal foundation of all digital trust, you have to ask the question, how in the world do you protect something that valuable?
And believe me, the stakes could not possibly be higher. The fundamental rule is this. If your root CA is compromised, everything beneath it, every intermediate CA, every issuing CA, and every single certificate they've ever issued is now considered compromised too. A failure here isn't just a problem. It's an absolute catastrophe. It's game over.
So, how do you guard the master key? Well, the answer is kind of brilliant. You take it completely off the grid. The standard strategy is to keep the root CA totally offline, disconnected from any network. It's stored in a secure physical location, like a vault, and it's only brought online under extremely tight security for one specific job, to sign the certificates for the intermediate CAs. And then it goes right back in to lockdown. And for the actual physical security of the keys themselves, The pros use something called a hardware security module, or HSM. This is basically a digital Fort Knox. It's a purpose-built, tamper-proof little box designed to do one thing and one thing only: securely store those incredibly valuable private keys away from everything else. All right, let's put this all together. We've talked about the different kinds of CAs, this whole pyramid of trust, and the crazy security around it. But how does this actually affect you when you're just browsing the web every day?
So the next time you click a link and see that little lock icon appear, here's what's happening in the blink of an eye. Your browser grabs the website certificate and sees it was signed by an issuing CA. It then checks that signature, following the trail up to the intermediate CA. It then checks that CA's signature, climbing all the way up the chain until it hits the root CA, the ultimate trust anchor whose certificate is already built into your browser from the start. If that chain is perfect and unbroken, you get the lock. It's an amazing, lightning-fast stance of verification.
And when you really step back and think about it, it's pretty wild, right? Our entire global system of digital trust, this huge, complex pyramid, is basically balanced on the integrity of a handful of super-guarded, offline master keys. It's a powerful reminder that in our hyper-connected world, sometimes the absolute best security is just to pull the plug. So, what do you think that says about the nature of security and trust today?